I realized that I didn't actually officially introduce our Lions. This is the joy of doing it for the 5th time. So we have Dr. Yili, who is the chair at Pittsburgh and runs all kinds of large NIH-funded networks, including, you run PEDAL, correct, Don?
That's correct.
Yes. Dr. Richardson, who is vice chair of research at Mount Sinai and is truly one of the lions in the field of health sciences research, disparities, and community-based practice. Dr. Klein, who obviously does PE research and runs academic emergency medicine. Dr. Newgard, who's at OHSU, recently received a large R24 from NICHD and does really great pre-hospital and large data research. He's also the methods editor for AEM. And then Dr. Babarda, who is a toxicologist and military, recently moved from San Antonio to Colorado, and has given a number of plenary presentations over the year and is also very well funded. With that, next up is Dr. Davis.
Hi, my name is Hilary. I'm currently a PGY3 at the University of Rochester, but next year I will be the Wilderness and Medicine Fellow. Thank you for allowing me to present my talk on using TEG to understand coagulation at altitude. This is the 1953 expedition to K2, the second highest mountain on Earth. To the left is Ori Gilkry. He's a 27-year-old mountaineer from Iowa. When he was near the summit, he awoke from his tent and syncopized. A physician at the summit saw that he had evidence of a DVT, but no evidence of any pulmonary edema. Why would a healthy 27-year-old suddenly develop a venous thromboembolism at 8,000 meters? Thrombotic events are not infrequent at altitude. Research as well, but recent retrospective studies confirm that there may be an increased risk of venous thromboembolism in these environments. As those who pursue activities for altitude or work or leisure become more numerous, as this graph demonstrates on Everest, the need to understand clot formation becomes increasingly important, especially as people on antiplatelet and anticoagulant therapies become greater at altitude and resources become more limited. The effects of hypoxia and hypobaryism on the coagulation cascade and platelet activity remain largely unknown. There have been no studies of hypobaryism on the coagulation cascade, and which is unfortunate because research from NASA demonstrate that platelet dysfunction is apparent at hypobaric states. Doing research at altitude is very difficult, however, secondary to hemoconcentration, vascular trauma, and information or fitness of the participants. We hope that we could use TEG to assess clot propagation, stabilization, and dissolution in these environments. Briefly, TEG provides a constant rotational force, and clot stabilization and dissolution can be assessed, inferring in vivo inference of coagulation. The aims of this project is to determine the independent effects of hypoxia and hypobaryism at clot formation. We expect to see significant differences in TEG parameters at this time. The second aim is to determine whether there's an interaction between the two. We suspect there may be a synergistic effect. To do this, we plan on using University of Colorado's altitude chamber as demonstrated to the left and doing 4 different states: normobaric normoxia, normobaric hypoxia, hypobaric normoxia, and hypobaric hypoxia. These states roughly become equivalent to 7,257 feet. We plan on using a healthy cohort of volunteers and excluding anyone who's born above 1,500 meters or have traveled to altitudes greater than 1,000 meters in the past 3 months. What we plan to do is, over the course of 9 days, have volunteers sit in an altitude chamber and draw blood at 0, 3, and 6 hours. Within 30 minutes, TEG will be run, and from that same tube, we will withdraw APTT, INL, and D-dimer as well. We will also send subsets of this for thrombin generation assay, as we expect that people at altitude might be more hypocoagulable, and generate more thrombin and generate it at a faster state as well. Subjects will undergo a 3-day of washout period before they undergo a next altitude chamber session. All TEG parameters we will be measuring. We expect that the O and K factor to decrease, alpha angle, and the maximum amplitude to increase, but not exactly sure what's going to happen to fibrinolysis at this time. But I think the study is important because we may, from this, further counsel patients of the risks of altitude, which is applicable in military environments. And also there's a higher population of elderly patients retiring at altitude as well. It also may lead to changes in chemoprophylaxis at altitude and ultimately provide a greater understanding of coagulation in hypoxic disease states such as COPD. A little bit about me. I have a PhD in biomedical engineering. My research was in tissue engineering using fibrinogen to build scaffolds. I have some TEG experience briefly. I presented my resident research on a prospective clinical trial to determine whether we could use TEG to predict pulmonary embolism in the emergency department. The experience of basic and clinical research. I have many friends who can be recruited with tasty drinks. A little bit of University of Colorado. They have a supportive wilderness faculty. They have an altitude research chamber. They have institutional grants, and they also have a CTOI. And so I'm really excited to start this project. This is my proposed budget, and thank you very much.
All right. And I'm going to try and restart. I think you get points just for dealing with AV dysfunction.
Oh, no.
Hi, it's Don Neely again. Thanks for the presentation. Just a clarifying question. I noticed that you want essentially fresh exposure to the condition at rest. Is there any reason to think that there's a dose-response curve for either the hypobarism or the hypoxia, excuse me? And if so, why not have varying levels of exposure before you look at the TEG and the coagulation? This would give you lots of information about short burst exposure, but really wouldn't tell you much. Is the acquisition of clot in the clinical setting, is it almost always right up front, or is it further along? Because you're only asking part of the question. You're in the descriptive phase right now, so I guess my advice would be look at all the potential exposure.
I totally agree that there may be a dose-dependent effect. I think that how I'm phrasing this project right now is an observational pilot study, and to work within the realms of funding, I need to get the basic data first before I apply for a larger, possibly K grant. There is not a lot of evidence in published literature that describes whether people develop VTEs right when they get to altitude. In Colorado, for say, going straight from Rochester to Colorado, but I think it's definitely a possibility. It's just a big unknown right now.
We'll make it more distinct. Make them come from Louisiana or like New Orleans, then go to Colorado. Jeff might know better about this, but in essentially sea level clot, when we think of long-term immobilization and the risk of clot, it begins to rise after a certain period of time. It peaks and then it actually comes off. It doesn't ever go back to lower levels. But quadriplegic people, after 2 years, it's not that they don't retain clot risk, but it's not as high as it was 6 months after the event. And so that's a completely different timeline, different set of conditions. And I know you're describing, but this would only be informative on intermittent exposure.
Exactly, yeah.
So Jeff Klein again, and I study thrombosis. So being a shark, we're all giant narcissists, so I have to tell you a quick story about hypobarism in this whole area. In about 2003 or so, I published a paper on looking at transatlantic deaths in Charlotte and Mecklenburg area, where we looked, everybody that died at the airport got an autopsy, and we looked at the prevalence of pulmonary embolism. From that, as a series of actions, 60 Minutes came and did an interview with me that they were going to do on economy class syndrome. So I got the whole 60 Minutes interview, all the TV and everything, and it was really super cool, and I couldn't wait to do it. And then I was like waiting for it, and finally I had my contact, and I called, and they go, yeah, 60 Minutes didn't want it. We're not doing that. So they never did the interview. But based on that, I got pretty interested in this area. And I do just say your biggest challenge is you really need to demonstrate what you're going to do that's different in the past, because there's several papers that have done this at altitude and also with hypobaric hypoxia. So I'm not seeing what's different. I'm just going to throw a paper out at you that I'm not seeing you citing, but it's TOF, was in JAMA 2006, that really looked at all the coagulation parameters, very similar to what you're doing. And then there's another paper that just published in thrombosis hemostasis that did thrombin generation. It didn't do TEG. I got 2 TEGs in my lab. Honestly, they're cool, but they don't add a whole lot more to just like thrombin generation or standard, D-dimer coag stuff. So just trying to see what are you going to find that hasn't been found already?
I think what's different between the recent paper, that got published in thrombus and hemostasis, of course, is the TEG component, which I understand is little more than a cone and plate rheometer. But I think it's the controlled conditions with varying the hypobaryism. The recent paper only varied the hypoxia, and they did find a significant difference in the TGA. But the hypobaryism component is important because the platelet function is not assessed.
Yeah, you're not doing the platelet mapping part, though.
Not yet. That's a really more expensive, technique, but it's definitely something that could be added on into the future.
Do you have an offer, Jeff?
It's really not my interest. I'm not interested in wilderness medicine, and I don't see it as it's interesting to you. It's sort of a niche thing. Overall, give them some low dose of Pixaban and send them up there. I mean,
what was the altitude? It says in meters.
It's
translated.
meters. It comes out to 17,500 feet. The altitude was picked really to correlate with the altitude chambers already protocol. They do a lot of studies in physiology, so the setup's already done. And so we would be just hopping on to those chamber conditions already. So basically our funding is already there.
Yeah. You mentioned the military would be Air Force particular is interested in this type of thing, hypobaric hypoxia, but I don't think they've found a lot of evidence. I mean, again, deferring to Jeff here, that it's very clear that, especially duration, how long they're exposed to those environments, whether in an airplane or whether they're climbing on the mountains of Afghanistan or whatever. But there is some interest of having clots and hypobaric hypoxia with that organization in particular. I just don't know if TEG's the right answer, even though maybe has not been studied, it sounds like, yet.
I've been through the DOD with, you remember my debacle with them, two attempts. They're definitely interested in air transport, but they're interested in this intersection of injury and hypobaryism, so you'd have to kind of look at like an animal model.
Craig or Lynn, do you have to pass? Okay. So I'll weigh in as the moderator here. So what I'm hearing from our Lions is that they all think that this is interesting and amazing for a PGY3 to be doing this. They're a little worried about the novelty and about the applicability. So a question that I have for you as the Lions is, would you be willing to mentor Dr. Davis if there was a slight pivot in the question, or would you be willing to pivot slightly? Is there some aspect of this that you think would be novel or different?
I think the part that ER docs remain extremely interested in is the role of travel and understanding if the hypobaric insult that you get flying makes a difference. So, and maybe also just going to altitude, like going to Leadville. You know where Leadville is, right?
Yes.
So like just going there, I mean, does that really increase your risk? And if you live in that area and you're an ER doc in that area, do I need to think about it? Or do I need to counsel my patients that when you go there, you should take an aspirin or you should take some low dose apixaban? So if I could get you to phrase it a little more, imagine yourself in the emergency department and you're trying to think who's at risk. But I'm not so interested in exactly how you design the experiment, but if we could shift it a little bit to help answer that question, to add to how I'm going to counsel my patient in Indiana who's going to go to Leadville for some unknown reason about what their risk is. If you could help me do that, then I'd be much more interested. And I mean, even at the level of COI type thing, or a helper,
I would love that. I think that's a definite important question to ask, and if to broader audience.
I can't help you at this current question, but what I can offer to you is at the University of Pittsburgh, we do medical command for half the airlines in the U.S. So you flying home here in the audience, if you get sick and they don't ask one of your friends to come attend to you, it'll be one of my partners that's on the other end of the radio. The chances are very, very good about that. So if you got to the point of reframing the question, as Jeff said, in the commercial air travel space, we have lots of clinical information. Wrote a New England Journal paper a few years ago on what happens to people when they keel over in the airplane. By the way, usually they're drunk, if you want the answer. And nothing bad. Either the bad thing has happened, you can't do anything about it, or it's never going to happen.
Not PE.
Yeah. So, and the training of the person responding will dictate the clinical diagnosis, not the underlying condition. Think about that for a second. But I'm willing to get you hooked up with the person who oversees that, but it really is a dramatically different question than what you're asking right now. It has some overlap, but it's not the same thing.
Dr. Davis, so we have about 30 more seconds in your session. So between Dr. Klein, who's willing to spend a little bit of time reframing, versus Dr. Gilley, who has access to commercial data, do you have a preference or a choice or questions for them?
No, I appreciate both of what you guys are offering, and I'm totally willing to rephrase this question to ask a broader one. Would you still do it in an altitude chamber, basically, or would you just take samples of people at Leadville?
Let's talk about it. I think that you have to think about reality and feasibility, and there's no reason that you couldn't work with both Don and I.
Jeff will call Don whenever you're ready to get your contacts.
The thing about taking these samples in the environment, there's an appeal to that, but are you certain that the environment doesn't change the technology?
That's what
And
yeah.
the beauty of yours is it's a clean experimental. The downside is it's an experiment instead of reality, so you trade one off for the other. When I first heard your presentation, I wondered, well, if you're just going to take a tag up to altitude, how do we know that the calibration doesn't change and you're just measuring a machine effect?
Right.
All right. Thank you very
so
much,
much.
Dr. Davis. As I get ready for the next presentation, I do have to say, so this year's Lions, really this was far and away our most competitive year for applications, and I also want to give them all kudos for being brave enough to stand up here in front of these 5 people and share their ideas.